put them today. All right, so we want to go a half mile across this river, 6 miles down. So we got 3 options. Because if you remember from EVT, any critical numbers can be a max or a min, or the endpoints can be a max or a min. So if I come across to some angle here and find a place here and come down with this power line, we'd say this distance is X. So the endpoint would be, one endpoint would be if we come straight across the river, that would make X 0. And the last option is we could take and we could go straight from the power station underwater the whole way over here to this factory. And that would be when X would equal 6, because it's 6 miles down this way, and that would be where X is 6. So we got endpoints for X of being 0 to 6. So in other words, our intervals are 0 to 6 here. And then we got to worry about the time when we cut across the river at some point, could be anywhere in here. That could also be the minimum value to lay this power line down. So basically, we want to find the cheapest way to do this. So we got to find, we're going to call this D right here, this red one D. So hopefully we realize that we're going to put D across the river. Now D could be this blue part straight across, or that purple line, the hypotenuse, but D is going to be the distance across the river. So the total distance we are going to travel, do this problem is going to be that D going across the river, and then that basically 6 minus X, the 6 minus X going from wherever we get across the river down here. Okay, so we are going to have to get the cost here. So this is the underwater part. And this is on the land, putting it on poles, which is cheaper. So my cost function, let's put just C for cost, and we're going to use X. My cost function is going to be, let's see, going underwater is $8,000. So I got to go $8,000, and then what I need to do is I need to find out what this D is in terms of X. So 0.5 squared plus X squared would equal D squared, because we have a right angle right here, would equal D squared. So D is going to be the square root of that mess. So I'm going to put in here the square root of X squared plus 0.5 squared. So this is the underwater distance, that D going across the river, no matter what it is. And then plus, we got this part that is above, we're going to put on power lines going down from wherever we come across to this factory. And that part is only $6,000, so I got to put $6,000 in here. So this is the thing that we want to minimize. Our goal is to minimize, find the most economical path, meaning the least expensive. We want the least cost. So this is the function that we have to find the least cost of. So I have to do the derivative of this thing. So I am thinking of this part right here as X squared plus 0.5 to the half power. So I'm going to take and do the derivative and take a half times 8,000, which is 4,000. I leave this part inside the same. There should be a square right there. And if anybody sees me make a mistake on this somewhere, please let me know. So I took the power, 1/2 times 8,000, got 4,000. Leave the inside the same, subtract 1 from the 1/2 power, and then I got to go in and do the derivative of this, which is 2x. That's chain rule I just did with this. Plus, I got my coefficient of 6,000, and then the derivative of 6 is 0, and the derivative of x is -1. So I'm going to simplify this derivative. And let's see, I've got 2x times 4,000. That's going to be 8,000x over the square root of x squared plus 0.5 squared plus minus 6,000. Okay, so what I need to do here is I'm going to get a common denominator over here. So I'm going to multiply this thing by x squared plus 0.5 squared. And then the top part times the same thing. And then I got my common denominator, so I can put this whole top part over a common denominator, which I only need one of these. And again, if you guys see me make a mistake or something, or you're not sure, please let me know. So this is my derivative function right here. So then there's two things I got to worry about. I want to find critical numbers when c prime equals 0, or when c prime is undefined. Okay, so that means I got to take the top part and set it equal to 0. Squared. And again, if you set this bottom part under here, you'd multiply it by 0 to start, so it goes away. That's why you don't worry about the denominator. And then whenever this bottom part would equal 0 is another critical number. All right, well, first of all, I'm going to talk about this part. If I take any number and square it, I'm going to have a positive unless it's 0, but when I add this to it, this is still a positive. So what that tells me is that this never equals 0. So I get no critical numbers from this one. There's nothing from here because this never equals 0. Now, if you were to happen to solve that, you would get imaginary numbers. So that would also tell you there's no answer there. And then we're going to solve this one. I tell you what, I'm going to use my calculator just because of time. But we would add this over to here and then divide by 6,000 and square each side. So this is a doable problem. But I'm going to use my calculator and I'll show you what I'm going to do. I'm going to find that thing equal to 0 there. So I'm going to hit y equals. Oh, let me put my camera up here so you guys can see what I'm doing. Okay, so I'm going to type in that 8,000x minus 6,000 times the square root of, let's see, x squared plus 0.5 squared. Okay, so there's the equation right there. And remember up there at the top over here on the right to the right of my finger here is where we have our interval from 0 to 6, right? Because that's how far x can be. So when I do my window, I only want to go from 0 to 6. Okay, and I know this y is the slope of my cost. So I know my cost is probably going to go up. I'm not really sure. I'm going to go from 0 to 20 because it's going to cost me something. So I don't really need to go anywhere else. So let's graph this and see what happens. Oh my, that goes almost straight up. Let's see, did I want to find the 0, don't I? My bad. I got to put, come on. I got to be negative here. Sorry. I got to go negative because I want to find let's go negative 10 to 10. And we'll grab it again. So right there's my 0 from 0 to 6. That's the only 0 I have from 0 to 6, I think. My thing's still spinning there. It quit. So that's the 0 I want. So I'm going to hit second, calc 2, and I got to get below that. So if you look at these numbers here below, this is telling me where I am right now. So I'm way up at 5,000. So I got a long way to go left to get down because I got to get my blinker on the screen here. My cursor getting, oh, that says negative. I went by and didn't see it. Okay, so this is not showing up on my screen, so I got to make my window bigger. So I'm gonna make my window bigger. I'm gonna go from negative 100 to 100 because I have to be able to put my my graph on both sides of that. All right, so second, calc 2. I'm going to bring this thing back down here. There it is. All right, so there it is. I hit enter below. I go above, hit enter a third time, and there's my magic number. I gotta go grab my glasses because I can't see. .5669, blah, blah, blah. Okay, so let me write that down on the up here. So my critical number, I'm going to write it down first. If I don't, it will be gone. So my critical number right here is approximately 0.566, 5669, 467. I want to make sure I type that in right. 8,000x. Yep, that's it. All right. So there's my critical number right there. So what I need to do now is, again, my cost function is this function right here. So I want to find out which value is going to give me the least cost. Well, if I go, so this is, again, this function right here, there's no place that this is going to be undefined. So it's a continuous function. So EBT tells me I'm guaranteed a maximum and a minimum from 0 to 6. So what I'm going to do is I'm going to make a T-chart, and I'm going to plug in my different values for X, and I'm going to plug them into my cost function and find the least one. That's the one that's going to be the one I want. So I'm going to do 0. I'm going to do 0.5669467, and I'm going to do 6. So those are my endpoints, 0 and 6, and then this is my critical number. So I'm going to plug that into my function. So I'm going to put my camera back up here and move it over so you can see me plugging these in. And by the way, because that decimal number is so crazy there, that is going to be, I would have had to use a calculator to find that number, at least, or else I'd had a square root. So I moved that down so I could see my cost function right here. I'm going to quit this thing. I'm going to hit second quit. Oops, second quit. Okay, now I'm going to type in 8,000, and then I'm going to type in square root. Then I'm going to type in 0 squared plus 0.5 squared, arrow out of that, and plus 6,000, parenthesis, 6 minus 0. Now you're probably saying, why are you putting zeros in there? And I'm going to show you in a minute. I'm going to be able to plug the other numbers in there without doing anything else. So I'm going to hit enter here. So if I go straight across the river and down, that's going to cost me $40,000 to go that route. Okay. Then and then I'm going to put my screen back up here. All right. So then what I can do, if I hit second enter, it's going to type in what I just had. So now I can go back in here and change that 0 to a 6. I'm going to do my other endpoint. So if I put a 6 in there, if I go straight across the river or straight from the power station to the factory, this is going to cost me $48,166. And when you're talking money, we do cents, but I'm going to do 3 places anyway, because that's what we do in calculus. We go 3 places. Now, we would round that to 38 cents. You'd want to be careful to make sure the directions might tell you to round to the nearest cent. So far, going straight across the river and down is cheaper. And then I want to show you something else. I don't know if you remember, but on the calculator, the X value was that decimal number that I found. It was my, the X value was that decimal number, that 0.5669467. So I'm going to show you the X value is the green value right here above store. There's an X. Wait a second. Right there, there's a green X right there. So if I come up here and I hit alpha, and then I come down here and hit store, do you see that it put an X? Come on. There, you see it put an X in there. If I hit enter, do you see that that decimal number we found for X is still right here? That's even more of the decimal than I wrote over there on the problem. So what I'm going to do is I'm going to now plug that thing in where the 6's are. So I'm going to hit second. oh no, I got to go up and highlight because I did it something else. So I got to go up and highlight this thing and hit enter. And that puts that back in there, but I'm going to come over here and I'm going to plug in that answer. So I'm going to hit second negative, which is answer. That's that decimal number right above there. I could put X in there too. And then here I'm going to hit second answer and hit enter. And there's the cost if I go at a diagonal across there. That is 0.5669467 miles down the river. So it'd really be right in here somewhere. But this number would cost me $38,645.75, but we're going to go to 3 decimal places for this class. So this is the cheapest, the most economical path is starting down the river, 0.566, this number miles. The most economical path is to move that far down the river, which will cost me this amount of money. And you should write that in a sentence. Okay, so that's number 15. We're going to go on to number 16 now, because somebody wanted 17. So, and I'm using this one because it said, now we're going to do the same rectangle area and build it as in problem 16, but now the builder's going to builder something $800. Oh, has $800. That should be the word has $800 to spend. What's the largest area fence? So we're going to do this one up here. So a rectangular fence using 2 types of fencing. The front and back uses the fencing costing $5 a foot, while the sides cost $4 a foot. So you got a fence that we're going to say is a rectangle because it says rectangular area. And it says that the area of the rectangle must contain 500 square feet. So we're going to call this side Y. And we're going to call this side X. So this says the area has to call that. What should be the dimensions to minimize the cost? So this problem right here, we want to minimize the cost. That's the goal. So cost function is our main deal. So you're supposed to know that rectangles have equal sides opposite. So 4x plus, I'm sorry, I said 4x, 2x plus 2y would be the perimeter, right? And then we're going to call this x the front and back. So you should probably say x is the front and back. It costs $5 a foot. So if I take all the fencing times 5, that's going to be the cost of the fencing in front and back. We're going to put a cost function again. And then this function is times $4 because it's the side fencing. It's only $4. So this is what we want to maximize. So our maximum cost function is going to end up being 10x plus 8y. This is the function that we want to minimize right here. Now, the other thing we know is we want 500 square feet of area. So the secondary formula is the area is length times width. And we want that to be exactly 500. So this is the secondary function. So we want to solve this for a variable and stick in to this so we only have one problem. So we're going to get 10x plus, and we're going to get 8 times 500 over x. Again, this is the cost function. And when I simplify that before I do a derivative, because again, I want to have my maximum benefit here of area of 500 with the least amount of cost. So this is going to be 10x, and then 8 times 500, I believe, is what, 4,000? And I'm going to move that x up to the top because I want to do a derivative here. So then I'm going to get my critical numbers. So I get my critical numbers and do the derivative, I get this thing. And that would be x to the negative 2 that I'm going to stick under here. Okay, so I have critical numbers when C prime is 0 or when C prime is undefined. Well, the other critical number then is 0 because that would make this bottom part 0. And we would probably want to get a common denominator just like I did on the last problem. So you multiply that 10 by x squared over x squared. Okay, so that putting that equal to 0 would make this 0. But the thing is, if x is 0, that means I don't have a fence, right? I don't have a fence, so I know x has to be greater than 0. Now I'm going to take this numerator, this 10x squared, minus 4,000 and set it equal to 0. So I'm going to get 10x squared is going to equal 4,000 and divide by 10. So that's going to give me that x squared would equal 400. And I square root that, and x would equal a positive or negative 20. But we're talking distance, so you don't want negative, you only want the positive 20. So our critical number is 20. So I want to make sure this 20 is a minimum. I want a minimum. So I'm going to make sure that 20 is a minimum by doing our number line for C prime. And I know I got to be greater than 0, because if I'm less than 0, I am not going to have a fence at all. So I'm going to plug the number 1 in right here. If I plug 1 in, I get 10 minus 4,000 over this. This is a negative, so my slope's going down on that left side. And then I'm going to plug, let's plug 30 in. So that would be 900 times 10, that's 9,000. So that's a positive, and that's positive forever. So this is positive. So I know that the minimum value of this has to be when x is 20. So when x is 20, y is going to be 500 divided by 20, which is going to be 25. So this says, what would the dimensions of the rectangle be in order to be a minimum cost? So the dimensions would be 20, let's see, we're talking feet, right? 20 feet by 25 feet to minimize the cost. And that's good enough. Now, if we wanted to find the minimum cost, we would stick 20 and 25. You could put those into here, or you could just take the 20 and stick it into this one. Either one of these would be okay. Okay, but it didn't ask what is the minimum cost, right? It said, what should the dimensions be? And if it said justify, you would say, because C prime changes sign from negative to positive at x equals 20. All right, we're going to come down here to this problem now, and this problem says the same rectangle area is to be built as in problem 16. So we got these same problems here. Now the builder has $800 to spend. Okay, so this changes it up. So now it says, what's the largest area? So the largest area means that's the formula that is our primary. So area has to be x times y. This is our primary because, again, we want the maximum area. So whatever we're maximizing is the thing that is our primary. Just like up here, minimum cost meant cost was it. And now we got $800 to spend, but everything else is the same. So if you remember, this was the cost function, right? So we get to put 800 in for that C of x equals this thing. So now we got to use this to solve for a variable and stick over here. So I'm going to solve this one for y. So I need to subtract 10x from both sides. And then I'm going to divide by 8. And we could simplify this if we wish. But then I'm going to come over here and stick this in over here. I guess maybe I will simplify this. So 800 divided by 8 is 100. And that would reduce to 5/4 x. So I'm going to go ahead and put this over here. So I'm going to have x times 100 minus 5/4 x. And then I'm going to distribute my x, get a equals 100x minus 5/4 x squared. And now I'm going to do the derivative of this to find my critical numbers. So a prime is going to equal 100 minus 5/2 x. So again, critical numbers are going to occur. This has no x in the denominator, so there are no places a prime is undefined. But we can find where a prime equals 0. I'm going to put none there because variables aren't in the bottom. And over here, I'm going to put this thing equal to 0. So I'm going to add 5/2 over. And I'm going to multiply by the reciprocal of 5/2, which is 2/5 on each side. So this 2 and this 2 reduce, 5 reduces, and I got x equals, see, 5 reduces with 100 to 20. 20 times 2 would be 40. So x is 40. Now again, I am trying to maximize the area. So I want to make sure that 40 is a maximum for a prime. Okay? So I'm going to stick 1 in here. So 100 minus 5/2 is definitely a positive. So this graph is going up on this side. Then I'm going to stick in 50 here. So 25 times 5 is negative 125. So that's a negative. So I hope we can see that's going to be a maximum right there. Okay, so it says, what is the largest area the fence can be? So what that means is X is 40, so Y is going to be 100 minus 5/4 times 40. So that reduces to 10, so that's 100 minus 50, that's 50. So the largest area is 50 feet by 40 feet, which is 2,000 feet squared. And again, because A prime changes sign from positive to negative at X equals 40. So there's all 3 of those problems done for you. And I'm going to pause this video for a minute and see if we got any other questions. And I have not looked to see if I've